Problem 1.3, calculate the resistance R of the following object if the material has the following specifications. I'm given a resistivity at temperature 20 degrees and a temperature coefficient, but I see that my object is operating at 80 degrees Celsius. So what I'm going to do is, before moving to the next steps, I'll just use this equation to get my actual resistivity. So if you plug in the values, you'll get that our new resistivity is just 7.11 times 10 to the negative 8 ohm meters. So whenever I use rho from now, it's going to be this value. Now, as far as our resistance of the object, what I see is a rod of 4 centimeter diameter that gets transitioned to a 1 centimeter radius rod. So to analyze this, what I'm going to do is splitting this object into 3 sections. So now that I have these 3 pieces, the first object and the third object look familiar to me. I'm going to use my equation that says rho L over A to get their resistance first, and then I'm going to worry about number 2. So R1 is equal to rho L is 0.1, converting everything to meters, and my radius is 4 centimeters squared. This is going to give me 62.5 divided by pi rho. And my R3 is rho 0.05, which is my length, divided by pi. My R is 1 centimeters, which is going to give me 500 over pi rho. The large difference between object number 3's resistance and 1's resistance is because of the area difference. So if I add the resistance for object number 2, at this point I would have just added them together and I would have got my equivalent resistance, but I don't. So let's figure out a way to calculate the resistance of this object now. So the area of this object is decreasing as my length goes forward. So that means that my resistivity is going to be increasing as I go forward as well. So to calculate the overall resistance of this, I'm going to need to divide this object into tiny lengths of dl and accumulate the resistance within the 2 centimeters length. And that's translated as the integral from 0 to 2 centimeters of rho dl over A, or I should say 1 over A dl. So since my area now is dependent on length, I could say that it's 1 over AL. So I need to find an equation for my AL, which is equal to pi RL squared, because pi is just a constant. And to get an equation for my radius, I can plot it first. So at length equals to 0, my radius is 4 centimeters. And at length 2 centimeters, my radius is just 1 centimeter. So it goes down like this. If you were to draw the entire object from the side way, it would have been this. This is why you would have been seeing it. But radius goes down from 4 centimeters to 1 centimeters when length reaches 2 centimeters. And so my RL would be the slope of it, which is -3/2 times L plus the y-intercept, which is 4 centimeters. And we have our RL now. So we can literally integrate this function and get our answer. So then R2 is rho. I'm going to take it out since it's constant in our integral from 0 to 0.02, 1 over pi RL squared dl. So what is this integral? I need to get an identity for this integral. So the one that I found is the following. 1 over ax plus b to the power of k. If we integrate this function, our function is the following. A times 1 minus k times ax plus b to the power of k minus 1. So you can use this for any kind of function. If our radius was something else, it was something like this, it was a squared function, 1 over x function, whatever function that you're given, you can use this integral to solve for it. So here, my 1 minus k is just minus 1, because my k is equal to 2 here, and my a is -3/2, and my ax plus b is just -3/2 L plus 0.04. When we subtract 1, it's just going to be this. So this is going to be our integral value, which I'm going to simplify it with the following. I'm going to say it's rho over pi 2/3, because I'm flipping the -3/2, which multiplies to this -1, times 1 over RL integrated from 0 to 0.02. And to simplify this further, it's going to be rho 2/3 pi, taking out all the constants, and I'm going to have 1 over 0.03 minus 0.03 plus 0.04 minus 1 over 0.04. And this is going to give us 100 minus 25, which is 75. So then our R2 is equal to 50 over pi rho. So now you can go ahead and add this to R1 and R3 and get your overall resistance of the shape.